Okay, so I've got my vector normalized. One thing I need to know is I need to know what direction it's pointing in, and the reason I need to know that is because I want to apply that angle and rotate this arrow. This is a debug feature only. So I use vector to angle, and I extract the direction the vector is pointing in, which turns it into a simple angle between 0 and 360 degrees. Then I do a trick. So in Corona, actually Box 2D, when you apply a force to an object, if you apply a force of, let's say, 10 to an object with a mass of 1, and you apply the same force to an object with a mass of 10, the object with the larger mass is going to be less affected by the force because it's got more mass to move. Same amount of force, more mass to move. The second object doesn't move as fast. It doesn't get accelerated as much. So because I wanted to have consistent behavior in my game, I do what is called a mass aware calculation. So I know that I want to push my object with this field common gravity mag, which is just a number in common equal to 10. So I said I want to push it with a force of 10, but then, let me find the code, sorry. I don't know what the mass of my character is. I could decide later to make my character a little bit bigger or a little bit smaller, but I don't want that to change the mechanics of the game and like have put a lot of effort into getting the game to feel just right and then say, that character needs to be just a little bit smaller.
Hey,
I make
Ed,
it a little bit smaller, and then suddenly my character's like jumping higher and moving faster. So what I do,
Ed, so um, what exactly is that going to make us do? I mean, math aside, what's the end result?
okay, the end result is I make a circle this big, and I
Uh-huh.
push on it with a known force.
Uh-huh.
It moves a certain amount. Boom. See, it jumps out like that. But now, if I push it with a bigger force, let's just change the force. I'm sorry, that was my jump force, so that'd be... If I push it with a bigger force, it really jumps out,
Oh, so we get a much different result.
right?
Hmm.
So the problem here is the same thing can happen. I'm going to go back to my original. Now, I'm playing with the jump value and not the value for gravity, but it's the same concept. But now let's say that here I go, let's make my player 1/4 of the size. That's the itty bitty guy. Do you see how it jumps out the same distance as it did previously? So
Right.
no matter what size I make it, it's always going to jump out the same distance. Now the reason it's doing that is because I made a mass-aware calculation here, where I took the player's mass and I took the number that I'm jumping by or the gravity force, and I'm adjusting it by the mass. So the bigger the mass, the bigger the end force. The smaller the mass, the smaller the end force. And because these are linear, they change equally with each other, I can keep my game playing the same way and feeling the same way, even if I make micro adjustments to the size of my player. So example, let me show you what happens if I take the mass awareness off. So this is my mass aware code, and I'm going to take the mass part out of it, the mass calculation, reload it. Now, I made my character 4 times as small as it was previously. Now when I jump, it jumps much higher. Or if I make it super, super, super tiny, let's make my character like super tiny. Let's divide this by 10. Load it. Itty bitty guy. Now it jumps off into space, never to be seen again. So, a lesson here is if you want to avoid this problem, keep in mind the mass of your player. Then, as you go along and you make little tweaks to your game doesn't start playing differently. It always plays the same.
Okay, so you knew these things were going to be an issue.
I
So
knew that would be
you
a
had built it
problem
into the
from the
calculation.
get-go, so I
Yeah.
just put the code in there.
Yeah. Otherwise, you wind up going in and tweaking individual variables and trying to get everything to feel right, and spend a lot of time
Right.
doing
You
that.
spend all this time getting the game to go just right, and you're like, the character's a little too big. I'll make it smaller. No problem. Why is my game not playing the same anymore?
Right. Yeah. Yeah. It's the iterative part of game design that becomes a beating if you don't set it up right.
Exactly. So I'm doing a terrible job of describing it because I'm pausing too much here. Where's mass? So
Well, it's hard to describe a calculation, right? Visually describe a
it
calculation.
is, and I'm struggling with the idea that one, I'm probably not doing a proper job of giving you the mathematical terms, and two, maybe people don't have the math concepts. So I'm trying to sort of like twist it around and say an arrow pointing this direction that's this long. So because that's what these things are. When you look at them on paper and you go to school and your teacher says, here's a vector. They draw an arrow on the board. You're like, no, that's an arrow. That's not what's a vector? I don't know what a vector is. I know what an arrow is. So an arrow is just nothing more than a visual representation of something that points in a certain direction and has a certain length. And that is the definition of a vector. Points in a certain direction, has a certain length. And to do all these calculations for gravity, we need vectors, because vectors tell us how much does it go in the x direction, how much does it go in the y direction. Boom, apply that as a physics property, done. So we got the vector that tells us the direction that the force should be pushing the player. We have calculated the magnitude, which is how long the vector is going to be, how hard is it going to push on the player. And then we take our vector and we scale it. So we took our vector that was length of 1 and we made it the length of magnitude. And then we store that in a field called myGravity. So I have a tendency to do this in my games, in apps. I know that there's no field on display objects called myGravity, so I'm safe to store some data there. So I want to store the vector, which is a table, on the player to use it later. I'm going to calculate it here. I do it here in this nice little bit. You can separate this out and use it in your own code other places. But at the end of the day, all I've got is I've got my player object with a field called myGravity containing a vector which describes a force pointing in a certain direction with a certain magnitude or a certain strength. Then later in the code, remember how I said every frame we do this? So we calculated the distances, we calculated the gravity, and then the very next step is I simply say apply force to self, which is the player, and apply it in myGravity X direction, myGravity Y direction. Sorry, it's highlighting. And apply it at the center of the body. So in other words, let me change the size of my player so we can actually see that guy again. We got our player. We got this vector pointing down. We got a force that we calculated out of that vector. And I'm saying is in the middle of the object, apply a force that points in this direction. And that cause, when I unpause the game, will cause our object to move in that direction. And that is the essence of a localized gravity.